All right. So we're going to talk about methods. And as I mentioned, methods are very similar to functions in C++. So if you are okay with them in C++, you should be okay with them in Java. There's a couple extra things in Java that we have to talk about and go over. But also, one nice thing about Java compared to C++ is that you don't have to write the prototypes at the top for the functions. So when you do methods in Java, you don't have to put at the top that you have those methods, and you don't have to put them before main. You can put them after wherever it searches in your program. So that's one nice extra thing that you don't have to do, but you do have to put some extra things in Java that we'll talk about. So they have their trade-offs. So all right. So hopefully you know why you had functions in C++. Hopefully it was to break down your program to make it easier to maintain. So if you feel like you're doing the same thing over and over again, then you have to say there's a better solution for this. There has to be a better way. And so we break it down into methods so we can repeat, because ultimately, if you get a really nice method that you might reuse in the future, you can save it in a file and take that file into projects down the road and keep reusing it. And then you can have a collection of methods that you find are helpful in your files, and you can give them to other people. You can, zip them up and send them to people for a library. They can use them in their code, and we're not rewriting and reinventing the wheel over and over again. So we're trying to think, how can we separate this that logically makes sense and break it down into methods so that we can reuse it, we can share it with other people, and we also makes your program more easy to maintain, because if you're doing something and you're just copy and pasting over and over again, it's more likely to make a mistake than if you have it in a method and you're just calling that method, then you can just change the method and it changes everywhere that you were using it. And so it's much easier to work with, although a little bit more complicated to think about, but much easier in the long run to work with. Okay. So we were using methods all along, and you may not have known it, but print line is actually a method that Java has that prints to the screen. And then another method that we use was parse int, and that actually changes a string to be an integer. And so when we do this, sometimes your methods will return and sometimes they won't. And we talked about that in C++ class. And so like print line doesn't return anything. It just prints to the screen. It's not a returning method. But parse int returns an integer. So when you get that integer back, so it's going to take and parse the 700 as a string to be 700 as an integer. And when you get it back, you have to save it somewhere or you have to use it. Because if you do a method that returns and you don't use it, then you lose it. Okay. So if it's giving you back a value, then you have to either save it or print it or do something with it, put it in an equation. But if you don't do something with it, then it gives you back the value and it floats off into space and you don't have it anyways. So if you ask it to do this part here on a line by itself, NetBeans most likely will tell you that this code is not really doing anything. I don't know how it words it exactly, but basically if you do that, it's going to return the 700, but if you're not saving it or using it, then you're losing it. So it's basically telling you that's useless code because it does something, but you're not using it. So what's the point, basically? So, okay. All right. So whenever we start a method, it's called a method declaration. We have to say a couple key pieces of information. So first thing we have to say is the method public or private. So we'll start with everything being public, but in our everyday lives, we don't make everything in our lives public, right? So some things we want to stay private. And we're going to talk about public first, and then I'll give you some examples of private. But if you don't know, we probably make it public because public means you can access it from any file, okay? And so if you make it private, then you have to have another way to get there, okay? If it's in a different file. So it makes your life a little more difficult, but there are some things we don't want public, right? So we'll talk about those things. So first thing, we're going to make it public. It's again either going to be public or private, and we'll also talk about some other things that we can do later, okay? So the next word that you have is static, and this is probably the most difficult word of the chapter, okay? Static means, are you working with an object? Is this method being used on an object, okay? Now, if it's static, that means it's not being used on an object, okay? If it's non-static, we don't actually write non-static. We just don't write the word static. So you either put the word static or you leave the word static off. We aren't really creating objects for our methods to work with right now. And so a lot of our methods that we write are going to be static, but some of the methods that we use that Java has are non-static, and we'll take a look at those. They're working with an object. And so if when you're using the method, if you have to create an object first to use it, then it's non-static. If you don't create an object to use it, then it's static. So the strange thing is that when we did like the scanner, we had to create a scanner object before we could use it, right? So in order to use like next int or next double, in order to use those methods, we need a scanner object before we can do that, or it complains, right? So those are non-static methods. But the one that we could see, that JApp-Champaign, is not an object. And so you don't create a JApp-Champaign object before you use those. And so you just see the name of the class, the name of the method, and it lets you use it. You don't create a JApp-Champaign object. So you've never had to say, like, JApp-Champaign, give it a name equals new JApp-Champaign, because you don't create an object. So we'll take a look at some of the breakdown of that, but that determines, like, if you think about, are you going to need to create an object in order to do this method? If so, it's non-static, and we don't put the word static. If not, it's static. And again, right now, a lot of the things we write will be static. When we get to objects in the next chapter, a lot of the things will start being non-static, and we'll start mix matching them. Okay. So the keyword, the return type, you had talked about in your last class in C++. And so void means you're not returning. If you are returning, it would be a data type, like int, string, double, boolean. It would be any of the data types you have. It can also be an object. But again, we haven't talked about objects much, except for strings or objects. Okay. And then a name. The name should be describing in such a way that you know what it's talking about. So like, this is display message. I don't have any question about what this method does. Like, it displays a message, and I'm not questioning what does it do. If I just put display, I might say, what is it displaying, right? And so display message is clear enough. Now, I don't have to write in a sentence and say, this displays a displays a message, because that's just, there's too many words, right, to type. So you want to be short and sweet and to the point, but you want people to know what your method does. Like, you don't want to call it, you never want your methods to be just one letter. Like, you don't want to call it D for display, because like D can mean a lot of things. So it can be display, but if you think that's confusing, then maybe you need to put display message. So you might need 2 words. Sometimes you might need 3 to get your point across, but you shouldn't have to question, what does this method do? Okay. So you probably should never have just like a calculate method, because it'd be like, calculate what? Okay. Because you're probably going to have lots of calculations. So calculate BMI, calculate sum. What does it do? Okay. So the name, your methods should always start with a lowercase letter. And I should eliminate the word always from my vocabulary, because that's usually not true. Sometimes you can have like a constructor that but for now, they start with a lowercase letter unless you have a reason for them to start with a capital. So lowercase letters for method names, unless there's a reason in the future. We'll talk about some reasons for that. Okay, now in parentheses will go your parameters that you need. Now, parameter means data that you need in order to do this method. Okay, so what do you need? Like, if you're going to sum 2 numbers, then you need to have 2 numbers, right? So to display a message, you would probably think you need a message to display. But in this particular one, it's always going to display hello, which is kind of boring. But if you wanted to put in their parameter as a message, then you could change the message to not be hello. It could be something else. Okay. And so parameters give you options for your method to do more things, because you're getting input from the user. Okay. If you don't have any parameters, then you still have to have the parentheses, but that means that whatever you're doing is not relying on anything that the user is giving you. You're not getting any data to do it. So like, to print hello to the screen, I don't need any data from you. I can do that without that. Does that make sense to everybody? And then you're always going to have an opening curly brace and a closing one. Whether this goes on the same line as your method declaration is up to you, or whether you want to put it down here, but it should be at least lined up with the start of the method declaration. Okay. So I talked about this already, and they just kind of outlined. So the first part are called the modifiers. You should know return type from your last class, and then the name, and then the parentheses are where you would put your parameters. Okay. So just kind of breakdown of all of that. Again, the hardest word on here is probably static, because you didn't see that in C++, because one of the nice things about C++ is you can totally use it as a C procedural programming language without ever touching objects. And you can't do that in Java. So we get objects from the very start. And so it's good because you've been exposed to objects already. So when we start talking about them, we can start mentioning some that we've used. And as you go through it, I think that it'll make more and more sense, and you'll make more connections, and all of it will kind of grow together. But that's why I don't think Java is the best first programming language, because there's so much going on. But you have a basis now, because you took C++, a foundation, that you can take that foundation now, you can grow with objects, I think. So I do like the switch from C++ to Java, not starting with like Java. And so hopefully you're starting to feel a little more comfortable. And after this chapter, I hope you feel even more comfortable in the next chapter, objects, even more so. And every time we talk about a little more, hopefully by the end, you'll understand every piece of the program and you'll be comfortable with it. But That's one problem with Java is we can't be comfortable from the very first day because there's so many pieces that we have to talk about. Okay. You talked about calling a method in C++. It's, just using a method, invoking a method, executing a method, same terminology, but most people call it calling a method. That just means using it. So like if you write a method and you never use it, you never call it, then it'll never happen, right? So you have to call it. You can call it as many times as you want to, and that's where the reusability comes in. You can keep calling it. Other people can call it if you give them that method. And so that example that I gave you before, this would be an example of calling it because it doesn't return anything and it doesn't need any information from you. The parentheses are empty. There's no arguments in there, and there's nothing being saved. It's not being saved anywhere because it's just a void method. Everybody with me so far? Okay, perfect. Something new that you haven't talked about in your C++ class. We should start documenting now because I know we put our comments at the top, but when we are writing our own methods, we should document our method before we write it. Now, actually, what I would suggest is you write the method, then document, because what is kind of cool about NetBeans is when you put /**, and then you hit like space, it'll fill everything out for you. And so it'll put, if you have parameters in your method, it'll put all the parameters listed there for you. It'll put like the return type, it'll put the name of the method, and all you have to do is put a description of what each of those are. Now, sometimes what you name your variables pretty self evident. Like if you have a sum method and you call it number 1 and number 2, it's pretty obvious that you need 2 numbers and you're summing them together. But sometimes you need more description about what your method does. Like we might be a little confused about something, so you would describe it, and then you would put each of the parameters in case someone's just, maybe confused about what one of your parameters, the purpose, or what they're supposed to put there. This would be the place where you describe it. Now, why does the documentation, why is it /** instead of just like // on the end of a line? This documentation actually goes into what we call Java docs, okay? And so you have a set of Java docs, which I'm going to show you today, that Java has generated for you that says what each of their methods does and all of their parameters and all of that. We'll take a look at that. But you can start creating your own Java docs for other people to look at. So, and I know they can look at your code and see like // and read it, right? But this would generate an HTML file that has a description of everything, and it's in a nice format, and it's easier to read than going through your code and trying to figure out, they don't even have to, if you give them a file with all your methods and you create a Java doc, they don't even have to get into your code, because if they can read the Java doc, if you do a good job of doing that, then they know what everything does. They don't have to get into your code. They just use it. They don't have to go look at your Java code. And so that's the purpose, is if the Java doc describes it enough and we can understand it, we shouldn't be getting into code to look at it. Okay. All right. So we talk about, there's, sometimes people use them interchangeably, but really when you create a method, they're called parameters. Like they're setting up what data is coming to the method. That's called a parameter. And again, sometimes you might not have any, sometimes you have 1, sometimes you have 2. When you use a method, it's called an argument. So think of argument, answer, parameters, question, and like you're answering the questions. So if you have 2 parameters in your method that you declared, then when you use that method, when you call it, you have to have 2 arguments to match those questions. You have to have the same number of arguments as parameters, and they have to be in the same order. Because depending on if we're doing an equation, depending on what the equation is, if you put them in a different order, then the values go into the wrong variables and they get put in the wrong order in the equation. Depending on what it is, if we're just adding 2 numbers, it doesn't matter. But if we're doing something more involved and we have 2 numbers, it may matter what order they're in. Everybody with me so far? And that was same in C++. Okay. So the number, or the value, doesn't always have to be a number. The value that you put as the argument just gets transferred to the parameter variable name. Okay. And the variable name, make it so that we know what it is, like give it a name. So it describes like num, it could be n for num, or it could be number, just something that we know what it is. And make sure the data type that you're using for the parameter is the same data type that you have up here. So if you're taking an integer here, you shouldn't put a decimal number here. And now if it accepts a decimal number, you can put an int in there. That's okay. But if it's asking for an int, you shouldn't put a decimal to go into an int. Decimals don't go into ints, but ints go into decimals. Okay. So just make sure that the data types match. And so what's going to happen is 5 is going to get passed the num, and then num is just going to get printed here. Okay. And then if you have 2 values, just make sure the order. Now, if you're doing sum, it doesn't really matter because you're adding them together. But the 5 would go into the first parameter, which is num1, and the 10 would go into num2, and that would get used here. Now, as I said before, this is an integer and this is a double, but that's okay because an int goes into a double. Just vice versa, that doesn't work. Okay. Everybody okay so far? Okay, perfect. So in Java, all of what we do, unless it's an object, is passed by value. Okay. So when we are passing integers or doubles, they're passed by value. Okay. Now I know in C++ we had the way we could pass by reference, but in Java we don't have pointers, so there is no pass by reference. If you want to pass by reference, then you use objects. Objects pass by reference. So strings are objects, so they're passed by reference, but all the other data types that we have that are primitives are passed by value. And we don't have that way of changing the, and making it a reference variable. Okay. So again, I just mentioned the strings and in Java are a little unusual because strings are objects, and so they're passed by reference. And so there's so much you can do with strings. They're really involved. We'll talk more in depth about them later, but they are passed by reference. And so are all the other objects, but we haven't used any other objects yet. So that's the only one that we've used that we would work with. Okay, and as I said before, if you do your method first and then you go back and put the documentation in after, it actually highlights all of these for you, so you don't have to remember all the tags for all of them. So NetBeans, it depends on what editor you're using. If you're using Online GDB, you're not going to get any help. Okay, it's not going to do any of that for you. So that's what's bad about those online editors, is they don't really give you, they don't help you fill out anything. They don't help you troubleshoot as much. And so like Eclipse, NetBeans, probably even VS Code, those different editors, they'll help you a bit. And so I don't know if the other ones will do it, but I know NetBeans for sure. If you put the /**, it'll fill out everything that's in that method. If you do it after, now if you're doing it before, you're not going to have any help because it doesn't know what you have yet. So, okay. Now, we hopefully don't have to talk too much about this because you talked about this in your C++ class, but there's always something called scope of variable. And if you're declaring a variable inside a method, it's only good inside that method. Like it doesn't know about it in your other methods. And so that's why if you have like a variable in your main method and then you create another method, you have to actually send it to that method by way of parameter. Because if you just try to say number1 that was in your main method, it doesn't know about number1 that's in your main method when you're in a different method because they're completely different. Now, with that being said, if you have a variable in main called number1 and you have a variable in your new method called number1, they are in completely different memory locations. They're completely different, even though they have the same name. Okay, so you can have the same variable name in different methods. It's okay, but they are not the same because they're not in the same method. Does that make sense? So if you want to give them different names, you can, but you can give them the same names. Just know they're in different places, but they're actually different. Okay, and we talked about returning. Returning means that, data is coming back. So in this case, an integer is coming back and we save it into an integer variable. Okay, so if you were looking at a method and you wanted a method that returns instead of being void, instead of putting void here, you would put the return type. So like this one is an int, returns an int. You should never have more than one return type. You can only have one return type. A method should only be doing one thing, one activity, handling one thing to return. It shouldn't be doing multiple equations, calculations, and returning multiple numbers. It's just doing one thing. So you should only have one return type. You shouldn't have void and a return type because that contradicts each other. So it's always just, if it's void, it's not returning. And then if it is, what is it returning? Should be listed there. So, and I always have students that confuse this a little bit. Just because your return type is int doesn't mean that these have to be ints or that you have to have data coming in. Your parameters, I mean, usually it does work out that way because if you're, returning an int, you're probably bringing in an int or two. It just depends on what you're doing. So think of your parameters are what data is needed to do what you're trying to do. And then as you do it, as a result, what are you sending back? Now, you can do a calculation and print out the answer, but a lot of times that's not what we do because a lot of times in calculations, we return the answer instead of printing it. Why do we do that? Because if we are reusing this and other people are using it, and we're asking it to calculate something, I know sum is really easy. We can just put that. We don't even need to create a method for that. But let's say we're figuring out like the arc for a game. Like we're trying to figure out the arc. Like when we toss a ball, it's going to arc, right? Or we're going to create an Angry Birds game and it's going to arc. Okay. So we figured out it's actually a pretty complicated equation. So we figured out we want to share it with other people so they can put it in their game. So we create this method and we put it in a file and we share it, right? Okay, so what data is needed would be the parameter coming in. And then as a result, what would we return? We can come in. What would we return? Now, it wouldn't be efficient if it figured out the curvature of the arc and it sent you back the answer and printed it on the screen, because then you would need to read that and go put that into your program, and that just wouldn't work. Especially that couldn't be interactive because you're not always going to intervene, read the answer, and then put it into your program, right? You want it to just take that number and put it where it's supposed to go so it all functions correctly. So a lot of times you want the answer given to you so you can do something with it, so you can apply it to your program. You don't want to have to manually read it and then go apply it to your program. That just doesn't make sense. And so a lot of times we won't have the answer printed. We will give the answer back for a calculation. And then you get to pick. If you just want to print it, you get to pick how it's formatted, how you're printing it. Are you printing it in a message box? Are you printing it in an output? You know, what's it going to look like? How are you going to save the answer? We're not picking that when we do the method. We're not deciding that. So a lot of times calculations aren't printing it, they're giving back the answer. Okay, so in this case, the answer is given back to you for the sum. And I know sum is really easy and we probably wouldn't even want to write a method for it, but bear with me. It's simple so we can follow. The values go into here, the parameters, and then it actually adds them together and it returns the result. And that result gets returned right here and saved back into total. Okay, but if I didn't have the total equals there, the result would get returned and it would float off into space and we would never know what it is. Now, do I have to put it in a variable and then print the variable or work with the variable? No, I could actually call that method right from like a printout and just print it right in the printout, like right from the print line. I don't have to put it in a variable, then use it later. I could put it in another method that would print the answer for me, or I could put it right into a calculation. I don't have to have a variable. It can go into something else, but if you have a method that returns and it's not going into something else, then it's kind of wasted because it gives you the answer and you're not using it. Everybody following so far? Okay, perfect. Again, I don't think you really need to memorize these, although it's not that hard. The return is actually just that simple return because NetBeans is going to do it for you. Okay, returning a Boolean, the same thing. You're going to put the data type as Boolean. This one takes in a number. It's going to determine if that number is between 1 and 100, including 1 and 100. If it is, then it's going to set the status at true, if not false, and then it's going to return the status. Now, I like doing it this way as opposed to having the return be here and here, because it's more likely to make a mistake if you change your conditionals and everything and you're missing a return. Because if all your conditionals don't have a return or you don't have an else on there, then Java's going to complain because it's going to say you're missing a return even though you have a bunch of returns. If every single situation can't be accounted for to have a return, then it complains. But if you put the return down here after your conditions and you just set the variable, then it knows that it has something to return because it's outside of your conditions. And so it satisfies that need to have something. And so I think that's usually a more efficient way to do it. And then here, you can use that if it's supposed to be lowercase I, sorry. This is going to call this method up here, pass in 20 here to number, and 20 is going to get evaluated. 20 is going to set true because it's in between there. It's going to return true back to here. Now you can say if true, like you don't have to say if is valid value equal true. You can just say whatever it is, and if it returns true, like if true is true. And if you wanted not true, you would just put an exclamation in front. That would mean if it's false. Okay, you don't have to say equal false or equal true. So this means if it returns true, it's going to print this, and if not, it's going to print this. Everybody okay with that? Perfect. All right. So this one is going to return a string. Okay, so it's going to pass in the first name, pass in the last name. It's going to join those two together, but it's going to put a space between them so that, as the full name. And it's going to return it back. Now it's going to point to the reference because it's a string. Okay, but you're really not going to know the difference. It's going to, customer name is going to be the full name. And so, okay, so what I want to do is actually show you some documentation. So if you go to Google and you just type in Java API, okay, that's the documentation, or you type in Java docs, you should get a list. And if you want to know a specific number, like if you go to in NetBeans, I always tell you, And let me pull up NetBeans real quick. I always tell you to write your JDK at the top, and I always forget what it is. I think it's 22, but for some reason I can't remember what it is. So if you click about, it's 22. I was right. So Java 22. So if you want the documentation for that development kit, like 22, you can type in Java API 22 or whatever you have on your computer, right? If you get like a really old one, like Java 8, it looks a little different. It has panes differently. I actually kind of like the way it used to look, but maybe that's just because I'm getting older. But it was a little easier to follow. Like this was like, for example, let me show you. This was the old one we used to use that had panes. And I kind of liked it because it had all the packages here. And then when you clicked on a package, it had all the classes with that particular package. Now, here are the newer ones. This one's 19. I should probably go do, but they between 19 and 22 really haven't added anything we can use in here. They keep coming out with new ones more frequently. It used to be like every year or two. Now it's every like couple months. I think they're popping out a new one. So if you want to know what new stuff though, or what they have, you can go to the documentation for that particular one that you have. And then Java base is what we've been using in here, like the basic list of packages. Okay, so like if I click, I talked about this briefly. Java Lang, let me see if I can make this bigger. Okay, Java Lang is the basic Java language. So like this would be like your system out print line. This would be the integer.parseInt, double.parseDouble. All of those are in Java Lang, and we don't have to ever write an import for those because they're in here. So if you want to know what's in there, if you click Java Lang, you'll get the Java Lang package, and you don't have to ever import that because it's so basic. They said it comes automatically. Okay, so if you scroll down, you can see a list of all the classes that you have in there. Now, I think if you just search for, oh, here's the search here. Like system. Oh, that wasn't what I wanted. Okay. Let me search for integer. Okay, there's the class integer. And I'll go back to the system, but the class integer, you can also search. You can scroll through and see every different method that belongs to the integer. Some of them may make sense, some of them might not, because we're still kind of just getting started. But if you want to search through them and see what's available, that would be great. But if you want to search for like the parseInt method, because we're in the class now, you can search for that. Whoops. Clicked it. What happened? It's not going to let me search for it. I'm going to try something else. Okay, I do it up there. I'll do the search up there. Okay, so if I do the search for parseInt, it'll take me, you can just scroll down and look for it. But it takes me to like all the different versions. Now, see how there's a couple different versions for parseInt? This is called overloading. Do you remember that word from C++? Overloading means that it's the same method name with multiple, either different number of parameters, different types of returns that you can have, but it's the same name. And the reason Java knows which one to use is based on like how many parameters you give it. Okay. What data types those are. Okay, so we have, this one is the one we've been using, okay? And so it tells you here, this is the name of the method, and this is what it takes in. And then it tells you, it tries to explain what it's doing. So that's the description. That's like in your Java doc, see that would be your description. That's what would show up. And then here it tells you that this method is static. Okay, that means you don't have to create an object to use it. So when you use the parseInt method, you say integer.parseInt, right? You don't create an object to do that. So that's why we call it static. And it returns, this is the return type. It returns an integer. Okay, so when we're doing it, bring up my notepad. Okay. It looks something like this. Int n equals, and then we would do integer dot parseInt, and then we would put some sort of string in there. I'm not gonna, instead of putting a variable, I'm just gonna put the string version of 5. Okay. And so it should take that string version of 5. I know Notepad doesn't like my coding. Okay, just ignore that red underline. 5 is a string. should get parsed to be an integer and saved into n, okay? But when you're looking at this, first of all, I didn't have to do, I know this isn't like a full program, but I don't have to do any imports for this because Java lang is automatic import, okay? Now, this is the name of the method, parse int. This is what I'm taking in. This is the data, and that's why it's saying here, it's taking in a string, right? So it has to take in a string, and it's telling you it's going to return an integer, okay? So I want to talk about what this is, though. Does anybody know what that is? I want to take a guess. I know we haven't really talked about it, but well, it's not an object because it's a static method, so it's not an object. Okay, but it's a class. Okay, and that's the class that I'm in right now, integer. So I'm specifying. So whenever you use a static method that Java has, you'll put the name of the class, then the name of the method. Okay, whenever you use a non-static method, you'll put the name of the object, then the name of the method. Okay, so if you look at, you know, so this is a static method. So see, you can see here. Okay, but if you want to let's go look at something else for a second here. Let's go back to, instead of using Java lang. So Java lang also has double, it also has system. But if I want to check out another one, like the scanner, for example, if I know the scanner is part of the Java util, okay, and Java text was like the decimal format and the number format, those ones. But the scanner should be in here. I can just scroll down or I can search for it. But here's scanner. It's okay, and I can click on it. So this is the class scanner, okay? So when you do your program, and I'm just breaking down like little pieces, don't you do something like this? You do something like that at the top when you want to use scanner? Yes, because this is the package and this is the class. Everybody following? Okay, now, real quick, before I explain a little more, I did this, and you don't have to do this because I did it for you. I don't know if I can make it any bigger though, but this says Java base. I don't know if you can read that up there or back there in the back. In the Java base, you see that there's a folder called Java, and then there's a folder called util. That is just telling Java where you can find the files that it needs. And so there's one called scanner. I think I clicked on the right one. Here it is. Okay, so you can look for the scanner. Now you don't have to go extract this or anything. And actually, you don't ever want to look or change the Java code or the classes that are there. But I just want to show you what's going on. So I want to show you that when I'm saying Java util, I'm just telling it to go to a folder called Java util and then find a file called scanner. So y'all kind of getting that? Like that's what the import's doing. It's just telling it go to this folder, this subfolder, this file. That's all it's doing. Okay. So that's the only reason I, extracted that to show you that all those exist. Those files are in there. And so when I do that, then, and I know I don't have the main method or anything. I'm just trying to simplify and pull out the code. You would do something. Yes, it is for now because we're not doing it yet. Okay. So you would do something like scanner, and then you would see the name of what you want to call the scanner. So like I say something like input, right? Equals, and then you would say like new scanner, and then you would say something like system.in. Okay. Y'all kind of remember this? Doing this? That is creating a new scanner object, and the name of that scanner object is called input, right? So then I can go use it. Now, normally you would put like a system out print line that says like what they're supposed to type in, because otherwise they won't know what to type. But we are just going to skip to the part where we take in the data. I know that's bad because we should do like an output line. But when I want to take in the data, I would need to say the name of the scanner, which is called input, right? And then I would say something like next int or next double, depending on what I want to take in. What's going on? You take the checkpoint at the end of class. Okay. So it's locked, so you can't do it yet. Okay, so this is the name of the method, right? And it doesn't have any data coming in because it doesn't need anything from you to take in the input. And then the name of the object is input because that's what I named it up above. But do you see how like the difference between what the example we looked at before said the name of the class and the name of the method, and this one says the name of the object. So this is the name of the object, the name of the method. But I don't say scanner.nextInt because if I did, that would mean that it would be a static method, right? If I said the name of the class, the name of the method, it's static. And if I say the name of the object, the name of the method, then it's non-static. Everybody kind of see that? Now, this would be bad programming because as I have it right now, it's going to return the integer and I don't have it going anywhere, right? So this is where I would need to create like, and this is where we think about, does it return anything? And this is why you should create something over here to save it into, because if your method returns, then you would need to save it in something. And so if I look on here to kind of understand the documentation, you can scroll down and read all this. I think it's kind of useful. Some of it might be a bit much because you're just, again, getting started with all of this and it seems a little overwhelming, but I don't think it'll hurt, hopefully, trying to figure out what it's saying. But if you just wanted to actually search for like next int, it tells you what it does. And there's a couple different spots that it talks about next int. So I'll have to go down to the actual methods. And it has next int because that's also next int. So there's a method called has next int. Okay, but here's the one that I'm using. This one here, I know it's highlighting this one, but this one here is the name of the method. It doesn't have any parameters. It tells you what it's trying to do. It tells you what it's returning. But see how there's no word static on there? When it's non-static, we don't write the word non-static. We just don't put the word static. And so that's how you can determine whether it's returning or not. I'm sorry, not returning. Static and non-static is how you determine if you need an object to do it or not. Okay. So we don't create an object to do it. And then it's returning an int. Okay. Now this, you can see that it's overloaded because you have another version of it. And that version is requiring a parameter. Okay, but I don't ever use that one. That one, you can change the base of what you're working with. If you don't want to work with a number system of 10, you can work with a base of 2, or I don't ever use that, but you could. And so you can see all the wonderful things you can do by looking at the documentation. Another cool thing, like while you're looking at this, I hope that you'll try to start looking at this just as a heads up. If you go, let me go back again to the Java Lang, because I think this one's really interesting. Java Lang has a class called math. Okay, and you could search for it if you want. Okay, now go down a couple. Okay, so the math class, make sure you're in class math, has so many methods that you might find helpful. And so there's so many things in here we're not going to do. Like, for example, we can use a basic rounds method, but they have like a seal and a floor method if you're interested, if you want like a different type of rounding. And so if you're looking to do something with your program and it's a calculation, see if it already exists in like the math class, because it might already be in there. Doing cosine, tangent, there's all kind of things you can do, exponents and, you know, logs, and it's pretty long. So you can go down there through it and see what's already available so you're not rewriting something that already exists. And so this is where you can start looking. There's other tutorials out there that would probably help explain all this a little better, but it's not bad to get used to looking at the documentation and starting to understand, you know, what it's talking about, like with the, you know, the parameters, the return type, whether it's static, non-static, and what's going on, and trying to what I would do in your spare time, right? I know everyone has a lot of that. Is try to go through and see if you can find, if you look at imports that we already used, see if you can find the package based on the import, and see if you can find the class that you were using, and then see if you can find the method, and then just kind of look over it and see if it makes sense. Like, did you think, and ask yourself, like, does this method return something? Is this method static or non-static? And then look at what the answer is and see if it's what you matched, like see if it's the same thing you thought, because that'll help you kind of understand and piece things together. Like the more familiar and okay you get with looking at this documentation, I think the better off you'll be. Okay, so, and we're going to create our own documentation. So on Wednesday, we'll create our own documentation. We'll write some methods and create our own, so you can see how to generate a Java doc, but hopefully in the meantime, you can review a Java doc and then we can generate. Does anyone have any questions about this? Okay. All right, any questions about the chapter overall? Perfect.